Okay, so in this lesson, what we're going to learn how to do is how to translate information from one graph to another graph. So the three types of graphs that we're going to be working with are motion maps, position versus time graphs, and velocity versus time. So I've started out here with a motion map. A motion map simply shows movement in either one direction or the opposite direction. On this motion map, we're going to say that every dot represents 1 second. And then for every hash mark that I have here, it represents 2, 4, 6, 8, 10 meters, and so forth. So I'm going to draw an object that's moving at a constant speed. We start out at 0. It goes to 4 meters, 8 meters, 12 meters, 16 meters. That's constant speed. They're evenly spaced. And then at 16 meters, we're going to say that it stops. This object stops. When an object stops, we just drop down the dots. And then we're going to say it returns back the opposite direction. And it's going to go much faster this time. So I'm going to put it at 8 meters and then back at 0 meters. To finish off my motion map, I just show arrows to show the direction. And now I've created a motion map that shows an object that's moving at a constant velocity, one direction. It stops right here. There's no movement. And then it goes back the opposite direction. And this time it's going faster. I can tell that because of the length of my arrows and the spacing of the dots. Now, whenever I convert this over to a position versus time graph, there's two things that I need to do to create my position versus time graph. Those two steps are, first, I want to count my time. I want to determine how much time passed. So I'm going to determine time. And then the second thing that I determine is the distance. So I'm going to do number 2 is determine distance. So if I count up my time, each one of these represents 1 second, and we start with 0 seconds. We start on 0 seconds, like the beginning of motion. You start at 0, and then the timer starts. So here we have 0 seconds. Here's 1 second, 2 seconds, 3 seconds, 4, 5, 6, 7 seconds. Here's my 8th second, and here's my 9th second. So I know on my time versus my position versus time graph that I'm going to need to graph 9 seconds on there. Now, whenever you do a position versus time graph, the time always goes on the bottom axis or the x-axis. So here I'm going to draw my x-axis, and I'm going to draw out 9 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are my seconds. Okay, and the position or the distance traveled always goes on my y-axis. So here's my y-axis. And this time I have to determine how much distance. Well, it goes a maximum distance of 16 meters away. So I need to make this graph go up to 16. I'm going to go in increments of 2, 2, 4, 6, 8, 10, 12, 14, 16. So I label that this is meters. And I label each hash mark so I know where I'm putting my dots. So those are my 2 steps. I've now determined my distance, I've determined my time, and I've put it onto my position versus time graph. From there, I just need to take each point and I use it like a coordinate plane, and I put each point where it belongs on this coordinate plane. So my 0 second goes at 0 meters. So the coordinate plane is 0, 0. The next one, it's 4 meters, and that's at the 1 second mark. So I go 4 meters, 1 second. My second is at 8 meters. So I go 8 meters, 2 seconds. Then 12 seconds is at 3 meters. 12 meters is at 3 seconds. Then it goes to 16 is at 4 seconds. And then I remain at 16 for 5, 6, and 7. So here's 5, 6, and 7. I've got 2 more points to plot. My 8th one goes back to 8. So I go 8 and 8. And then my 9th second is at 0. Now I have plotted my position versus time graph. I'm going to connect these dots. And there we go. Now by looking at this position versus time graph, there's several things that I know. I know that in an upward slant, anytime that I have an upward slant, that is going to be positive velocity. So the upward slant is a positive velocity. My flat line, the flat line, or horizontal line, I'm just going to call it flat for room right here. My horizontal line, it's not moving at all. There's no motion. And then my downward slope, that is a negative velocity. It's a negative velocity because they're returning back to 0. It's going from a positive number back down, so that becomes a negative velocity. So now that I can see this, I know that this is a positive velocity. The person or the object stopped here, and then they went backwards, so that was a negative velocity. Now what I can do is I can take this information that I have in here, and I can convert it over to a velocity versus time graph. Now in order to do that, there's 2 things that I need to determine. First thing, to convert this, my first step, is I need to determine, once again, the time. How much time do I need to put on my velocity versus time graph? In this case, I just count up the seconds, 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. So on my velocity versus time graph, I need to put down 9 seconds. The second step is I need to determine velocity. Now, I need to determine the velocity. I need to determine the velocity for every segment of this graph. So there's 3 major segments, and those 3 major segments are any time that the velocity changes. So I start here with my first segment. It goes from the 0 point to where the person or object stops. This is my first segment, and I'm going to call this segment A. The next segment of this motion is when the person or object is stopped. And it goes from this point right here to this point right here. I'm going to call this segment B. And then the last segment is when the person is returning or the object is returning, and that's from this point here back down to 0. And I'm going to call this segment C. So I need to determine the velocity at segment A, determine the velocity at segment B, and determine the velocity at segment C. So let's start with the velocity of segment A. One of the things that's good to know is I need to know how to solve for velocity. And velocity is simply the change in distance over time. So I have the change of distance over time. So if I look at this first line segment, I want to find out how far did this object travel during that time. Well, from here to here is 16 meters. So this object or person traveled 16 meters. So I'm going to put that next to the line here. They went 16 meters. And I'm going to divide that by however many seconds it took them to travel those 16 meters. It's really easy to do. I just drop a line down from that top line, and I see that from here to here is 4 seconds. So they traveled 16 meters in 4 seconds. Here's my 16 meters. Here's my 4 seconds. So they traveled 16 meters in 4 seconds. If I divide 16 divided by 4, I get the velocity of 4 meters per second. The top line is super easy, segment B, because I know that anytime that the line is horizontal or it's flat, that there is no motion. Well, if there's no motion, that means that the velocity is 0 meters per second. I don't have to do any calculations. I could, but I'm just not going to. I'm going to save myself that time and say a flat line on a position versus time graph means that it's going 0 meters per second. Now I just have to determine the velocity of segment C. At segment C, we go from 16 meters at the top to 0 meters at the bottom. So that gives me negative 16 meters. The person traveled negative 16 meters. They returned back, so negative 16 meters. The time that it took, they started to move again at the 7-second mark, and they finished at the 9-second mark. So it took them 2 seconds to travel those negative 16 meters. I divide those two numbers, 16 divided by 2, and I'm going to end up with a velocity of negative 8 meters per second. So there I've translated my motion map into a position versus time graph. I've calculated the time, I've calculated the velocity for each segment. Now I'm going to translate this information into a velocity versus time graph. Now, velocity versus time graph, I'm going to draw my y-axis and then my x. Now, I know the maximum velocity that it ever went was 4 meters per second, so I need to make sure that I get to 4 meters per second, and the maximum negative velocity was negative 8 meters per second. So I'm going to make sure that on this, I have my positive velocities here, my negative velocities below it. So I've got 2 meters per second, 4, 6, and 8 meters per second. Now I'll label each hash mark. This, of course, is 0. And then on the negative side, I put negative 2 meters per second, negative 4 meters per second, negative 6 meters per second, and negative 8 meters per second. So now I've got my positive velocity and negative velocities listed. But I also have to include my time. And if you remember, our time was 9 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. And I'll just start right there. So my S for seconds, and then 2, 3, 4, 5, 6, 7, 8, 9. So now I've got my 9 seconds and I've got my velocities listed. Now I just have to translate the information that was on the position versus time graph and put it onto my velocity versus time. So let's go back. And I want to do one segment at a time. So I'm going to do segment A first. I'm going to translate segment A onto my velocity graph. Well, I have to determine the time. Segment A occurs between seconds 0, 1, 2, 3, 4. So from seconds 0 to 4, there's this constant velocity. That velocity, as we solved earlier, is 4 meters per second. So I'm going to go onto my graph, and from second 0 to second 4, I'm going to put a straight flat line at 4 meters per second. That's how fast the person or object was moving at the beginning. Now if I go back, now I got to translate line B into this graph. So this was A. Now I got to figure out, where do I put B? Well, if I look at B, we know that the velocity is 0 meters per second. Because it's a flat line, it's 0 meters per second on a position versus time graph. And that occurred between the 4 and 7 second mark. So between 4 and 7 seconds, this person was traveling 0 meters per second. So I go back to my velocity, and I say, okay, between 4 and 7, they were going 0 meters per second. So that's right on the line itself. So this is line segment B. Now I know I've got one more line segment to put on there, and that's line segment C. On line segment C, I've calculated my velocity to be negative 8 meters per second. So I know that I'm going to put the line on negative 8 meters per second. I just have to determine when did that occur. What occurred between the 7th second and the 9th second. So I'm going to go between the 7th second and 9th second, the person or object was traveling at negative 8 meters per second. So this is line segment C. All three of these graphs present the same information, but they do it in different ways. If I look at the motion map, I know I have a constant velocity. I just don't know exactly what that velocity is without doing the calculations. And I could, it's all up there. I know that they're traveling 4 meters per second here. I know that they're stopped right here. And I know that they're traveling in the negative velocity at negative 8 meters per second. I can translate that to a position versus time graph, and I can translate this information once again into a velocity versus time graph. So those are the three different graphs and how they interact one with the other. We never know which type of graph you're going to encounter as you go into your future projects in high school and college, but we teach you all three so that you're familiar with how motion can be graphed. I hope this helped. Thank you.